A block of mass 5 kg is placed at rest on a table of rough surface. Now, if a force of 30 Newton is applied in the direction parallel to the surface of the table, the block slides through a distance of 50 meter in an interval of 10 seconds. The coefficient of friction is. Okay. So, as usual, what we'll do is we'll first visualize, right? And then find a frame of reference. So, this is the visualization. A block is for 5 kg is placed at rest on a table of rough. So this is a rough condition, something that I haven't drawn here, my bad. It's a rough condition. Okay, now if this is a rough condition, what will act on it? Yes, friction will act on it. Force of 30 Newton is applied parallel. Okay, it's applied parallel. It slides a distance of 50 meter. Okay, so now we don't need a question. Now what we need to do is directly the answer. So let's see. So the visualization part is done. Now we need a frame of reference. We will use inertial frame of reference as a person standing on a non-accelerating frame, right? And he's visualizing things from here. Okay. So visualization is done. Frame of reference is done. The system is done. What is the system? The system is this block here. System is done. Isolated body. We have isolated the body here. Then we have to sigma fx and sigma fi. So this portion is not required now. Let us now try to focus on the given portion, given conditions here. So we have 5 kg, 30 Newton. Okay, it is at rest. So since it is at rest, we can say that this u is equal to 0 here, right? And if u is equal to 0 is given, if u is equal to 0 is given, it is also given to us that the displacement is 50 meter in 10 seconds. So the moment you see displacement and time, what comes to your mind? Exactly your displacement time relationship, which is S is equal to ut plus half at square. What is S? Given to us as 50. What is u? It is 0 plus half into 8. What is t? T is 10 square, 10 square. So half into 8 and square is 100. 0 plus 8 to 10 square is, wait, I have a mistake here. No, I have taken this transpose 2 to the LHS. So 15 to 2 is 100. So we have 100 is equal to a into 100, and therefore a is equal to 1, right? So the acceleration is 1 meter per second square. Okay, having said that, let us now move on to the free body diagram. So draw the free body diagram of this body. What are the various forces acting on it? The very first forces would be the force of gravitation, which results in mg. And since it is on a surface, this surface will exert a force on the block, which will be normal reaction on the block due to the surface, right? There is one other force, 30 Newton, which is acting parallel. And since it is moving on a rough surface, we know that force of friction would act opposing the force of caution. Sorry, the force which is causing the motion. Now, you may have a doubt here, which friction are we going to consider? Is it going to be static or that of kinetic? No doubt about this, because since the object is moving with a significant velocity, we can directly say that the friction acting here is kinetic friction. Now, if we apply equilibrium condition, what is sigma Fy is equal to 0? What is sigma? Why is sigma Fy equal to 0? Sigma Fy is equal to 0 because body is not moving along the which direction? Body is not moving along the y direction. If the body is not moving along the y direction, therefore the velocity Vy is equal to 0, therefore Ay is equal to 0, therefore m into Ay is equal to 0, and therefore F is equal to m into Ay is also equal to 0. Therefore sigma Fy is equal to 0. What does it mean when sigma Fy is equal to 0? When sigma Fy is equal to 0, it means that forces along the up direction are equal to forces along the down direction. What is the force acting on the up direction? Only one force, which is normal reaction on the block due to the surface. Therefore, we can write N is equal to forces down direction. The only force acting along the down direction is mg. Therefore, N is equal to mg. Now, what is sigma Fx is equal to? Sigma Fx is equal to ma. Now, how many forces are acting on the x direction? X direction, there are two forces. One is the 30 Newton force, and the other is the kinetic friction. And if we understand, if we focus more on 30 Newton kinetic friction, how do you identify the signs of it? Uh, what we need to understand is, what is the overall direction of motion? The net direction of motion is towards the right, because the body is moving towards the right. The net direction of motion is towards the right, and therefore what do we see? Maybe I'll just draw it one more time. This is the net direction of motion. How many forces are acting along it? There is one force of 30 Newton. What is the other force? The other force is the force of kinetic friction. All the forces which are acting along the net direction of motion would be taken as positive. All the forces which are acting against the net direction of motion would be taken as negative. Therefore, when you write down sigma fx, you will have two components. One, 30 Newton being positive, 30 Newton being positive, and the other kinetic friction being negative, and the other kinetic friction being negative. And what is kinetic friction is equal to? Kinetic friction is equal to coefficient of kinetic friction into normal reaction. What is normal reaction? Normal reaction is equal to mg, and therefore what we have is plus 30 minus mu k into n is equal to 5 into a. Now I hope I can just remove this from the board, right? Okay. Now we have 30 minus mu k is equal to, what is n? N is equal to mg, so this is equal to 5 into a. So we have 30 minus mu k, what's the value of mg? Should be 5 into 10, which is 50, is equal to 5 into, what is the value of a? We found out to be 1, so it is 5 into a. Therefore we have 30 minus 5 is equal to mu k times 50. What is 30 minus 5? It is 25. So we have 25 by 50 is equal to mu k, which is equal to 1 by 2. Therefore mu k is equal to 0.5. So what's the question? The question is coefficient of kinetic friction is here equal to 0.5.